Okay, so we're just going to take a look at a sample problem. It's a little bit of a repeat from yesterday, a bit of a minds-on activity. In this case, we're talking about normal sampling. So what is that? Sometimes what we'll do is we'll take data from a population, we do a sample, and we're assuming that it's following a normal distribution. So the note here says, in many real-life scenarios, samples are taken from a population which is believed to be normally distributed. With most values clustered around the mean in an approximate bell shape. So this is what they'll call the bell curve. With these samples, predictions about the population may be made. It should be noted that the larger the sample size, the more accurate the prediction will be. So the greater the data, the better we'll be able to approximate a normal distribution. So below what we actually have are real data from a number of years ago of the students, the 26 males. There are 26 males taking data management, and that data is included. So in this case, we will be assuming that it is height is typically denoted by a normal distribution. So we're going to take the sample data to answer these questions. Determine the mean and the standard deviation of these data using the chart attached. So we've got a chart that's on your handout. And what we're talking about here is it looks like the approach that's being used in this problem is to take a look at distributed data by setting up our intervals. So remember, we're going to include sort of midpoints here. We're going to include our frequency. We'll typically have our cumulative frequency. And then we're going to take our frequency times our x, which is, remember that our x is actually denoted by the midpoint. And then in order to calculate the mean, the way we calculate a mean for distributed data is our mean. In this case, it's all 26 students in the data management class. So we could make an argument saying that this is actually the entire population. So we could say that our mean mu is equal to the sum of the frequency times our midpoints divided by the number of students in the class. I'll show you basically our next page. The data has all been done. It's all been analyzed. This is done in a spreadsheet. I'll print this off for you guys to have it as well. You can go through to practice this question if you feel like you want to practice this some more. But these are questions that we've been, this is just like sort of the question number 13 from our test. If you didn't get it right, it's a good question to try to go through and you can check your answers. But in this particular case, the sum of our frequency times the midpoints, 4613.3. Oops. So that's 4613.3 over 26 males gives us a mean of 177.43. And then in order for us to calculate our, can I extend this page? No, can't extend the page. I can do it on the next page. In order for us to calculate our standard deviation, is the square root of the sum of our x minus mu squared all over our population of n. In our charts here, really, I would argue that should be a mu because it's a population. This would be our mu there as well. When we do that, we can see that the frequency times x minus mu squared, data point subtract the mean squared, that sums to 1787.065. All right, all over 24, and this yields a standard deviation of 8.29. We're asked to, assuming the data are normally distributed, what is the probability that the height of a male is greater than 185 centimeters? So these are questions that we looked at our previous note. So really it's about calculating Z-scores. So this is just repeating these questions using this real live data from the 26 male students, where we were given our data point of 185. We're trying to find out what's the probability that the height of a male is greater than 185 centimeters, given the fact that our mean is 177.43 and we have a standard deviation of 8.29. So what I'll do is I'll simply post the solutions to these questions A through E, and you can take a look. I don't think I need to walk you through it. It's a repeat of what we've already looked at in the last note. And then the next video, we'll take a look at the new information.